In this video, we are going to test the new Llama 3 models, 8 billion and 70 billion logical abilities versus WizardLM 8x 22 billion and also Mixtral 8x 22 billion instruct models. Also compare the results to Claude's Opus, Haiku, and Sonnet and GPT's latest GPT-4 and latest GPT 3.5 Turbo. So we'll input the total number of correct answers that we have gotten from these models into this chart towards the end of the video. But currently I'm displaying that we have 120 total test cases for each problem. And for the bumper problem, GPT-4 Turbo got all of them right. And for example, Haiku was able to get only 105 right. So this should give us a decent idea towards the end. Stay tuned. We will use two different difficult problem sets, a word puzzle, so to speak, a word and math puzzle. These problems have 5 sentences in them. The way we are going to test this, we are going to test every combination of shuffled sentence combinations because this problem was mentioned in Code Your Own AI's channel. This video right here, which was very interesting. Turns out a model can solve a logic problem in one combination of sentences and sometimes fails in other combinations. So within our code, we are actually going to test all combinations. We will use OpenRouter for this. You will have, if you wanted to download the code and run it yourself, you will need an OpenRouter API key. Code files for this project, along with the results, will be available at my Patreon. Link will be in the description. So these 3 scripts, split problem parallel, tests this combination, both for problem 1 and problem 2 by looping through Opus, Sonnet, and Haiku for Claude, GPT-4 and GPT 3.5 for GPT, and for Llama 70 billion, 8 billion, and the Mixtral and the WizardLM 8x 22 billion, using all in parallel, for each problem, using the thread pool executor. I will also include a script in which you can choose to chat with any one of these models, Llama 3 models, Mixtral, or WizardLM, just to see how it feels to you. We will be utilizing the OpenAI Unified, Claude Unified, and OpenRouter Unified classes I've created just to make our life easier. So let's begin. Let's begin by reviewing the results from Claude and the models. I have actually run this ahead of time for both problems. Let's begin by for the bumper car problem, which is probably the easier of the problems. So Claude 3 Haiku for the bumper problem got 35 correct and 15 wrong. Let's compare that to GPT 3.5 out of 120 combinations, that is. GPT actually got only 90 correct and 30 wrong, so Haiku beats there. Sonnet for bumper cars got 112 right and 8 wrong. And Opus for the bumper car problem got 117 right and 3 wrong. If you look at the latest GPT-4 for the bumper car problem, it actually got all of it right, so it's absolutely the king for this problem in any case. The Marcus problem is a more difficult problem. You can pause the video and watch this. Haiku for this problem actually only got 66 correct and 54 wrong. GPT-4 Turbo for this got 20 correct and 100 wrong. Sonnet for this problem got 55 correct and 65 wrong. And Opus got 107 correct and 13 wrong. And the latest GPT-4 got 98 correct. So Opus actually beat GPT-4 for this problem. The beauty of this script is that you're not limited to these 2 problems. You can actually insert your own problems. Just make sure that you have the kind of problems when the sentences are shuffled, the meaning doesn't change, which is the case with these 2 problems. So I've run a test case for these LLMs, but I'm going to delete them and run it in full. So I haven't seen the results, so it'll be a surprise for me as well. So I've gone ahead and deleted the results for the Llama 3 models and the Mixtral and Wizard. So we are going to run it from scratch. We are going to loop over the first problem and the second problem, and we are going to test 70 billion, 8 billion, Mixtral, and Wizard LLM for all combinations of these problems. Running 20 threads concurrently and testing all combinations. Again, using OpenAI router. So let's just begin. Let's see what happens. We are first testing the Llama 3 70 billion instruct. We have instantiated 20 instances with the 20 threads. You can, I'm printing the results here. You can actually go back up and see their reasoning. And we are eventually printing whether we gotten the result correct or incorrect. The answers to these problems, the first one is 23 yellow cards, and the second problem is supposed to be 24%. So the way I'm actually checking for the answers is I'm looking for 23 or 24%. If it's in the response, then it's correct. Then otherwise, it's incorrect. We have gotten our result for the Llama 3 70 billion for the bumper car problem. Let's look at, we also got the 8 billion result as well. Let's look at 8 billion. Actually, 8 billion got 106 correct and 14 wrong for the bumper car, the simpler of the two problems versus Haiku. So it actually beats Haiku and Sonnet. It's almost up there with Sonnet, just the 8 billion Llama 3. And as you remember, GPT 3.5 was actually 9%. It beats 3.5 as well. It's the 8 billion model. Let's take a look at the 70 billion. 70 billion actually got 117 correct. That is as good as Opus. Of course, with the bumper car problem, GPT-4 had gotten all of it, all combinations correctly. I will be reviewing the code shortly. I won't get into the details of the Cloud Unified and OpenAI Unified classes, but you can watch my OpenAI Unified API video just to see how I built them. I will quickly, maybe while we are running, mention how I built it. If you look at the Open Router Unified, I'm just creating a class while this is running. I'm just creating a class to manage message history, API keys, and actually be able to trim messages so we can actually handle the message history length. You can also handle streaming and system messages. So I just have some useful methods to set system messages, for example, and to get responses of both as streaming or not. So that's pretty much it. It's just a helpful class, like a utility. You can also watch my Easy Opus Autocoder to find out more in detail about the Cloud Unified, which is pretty much the same thing, or the Cloud API. We got the results for Mixtral in for the bumper car problem. If you look, actually, Mixtral 8x22 billion got all of it correctly. The only other model that got the bumper car fully correct was actually latest GPT-4. As if you remember, Opus actually got 3 wrong. So that's pretty impressive, actually. And the Llama 370 billion actually got 3 wrong, just like Claude 3 Opus did. Maybe got the results for the bumper car for WizardLM. Actually, WizardLM got 4 wrong. It's pretty good, but I'm surprised because I heard that maybe Wizard was better than Mixtral. But so far, Mixtral is doing very well. So now we've tested all 4 models with the bumper car problem. Now we are working on the other math problem, Marcus problem. If you're enjoying my content, you can find all my videos and search through them at my website, echohive.live. And if you're a patron, you can easily find code download links. When you become a patron, you'll have access to all the project files that I work on. It's a great benefit if you want to experiment quickly or get ideas, because I do this every day so that you can save some time yourself. Okay, we got Llama 70 billion and 8 billion for the bumper for the Marcus problem. Let's see how 8 billion did. 8 billion actually did very badly. It only got 10 correct and 110 wrong. If we remember, Haiku actually had gotten 66 right. Let's see how the 70 billion model did with the Marcus problem. It got 85 correct versus Sonet's 55. So actually beats Sonnet. Opus got 107 right for the Marcus problem. And GPT 3.5 was only able to get 20 correct on this one. So now up next is Mixtral and WizardLM. I actually ran into an error, I believe maybe from the API. Not sure why that happened, but that's why we couldn't get the results for Mixtral. But this is a good opportunity. I can show you how you can actually change which models to choose and limit it to a different problem set. I'm just going to override here model names to just Mixtral and WizardLM and problems to only the second problem. And I'm going to run it again to get the results for Mixtral and WizardLM. Actually, the problem was that I ran out of credits with Open Router, so I added some more credits, and we are continuing to test the models, Mixtral and Wizard currently. Okay, we have the results in for the Marcus problem for Mixtral, and Mixtral actually really did badly in this one, only gotten 39 correct. Remember, in the bumper problem, he was able to get all 120 correct, so this is a little bit disheartening, actually. Remember, even Haiku did 66 correct for the Marcus problem, but it's the more difficult problem. Let's see what WizardLM did. We only got 49 right. Sonnet, in this case, did 55. And just to remember, GPT-4 did 98, and Opus did 107 in this problem. So I'll go ahead and input these into our chart, and then I'll be right back. Okay, so this is the final tally out of 120 total combinations for each of the problems. GPT-4 and Mixtral 8x22 actually did it perfectly for the bumper problem. Opus did really well. Sonnet did really well. So did Haiku. And they all did very well, actually, in this one, except maybe GPT 3.5 Turbo. As far as the markers problem, Opus definitely clearly is the winner. GPT-4 is also a very close second. And the next best one is Llama 3. Llama 3, 70 billion. After that, we have Haiku, and then Sonnet, and then Wizard, and Mixtral. So this interesting thing is that Mixtral did really well on the bumper problem, but utterly got confused in the markers problem. So was WizardLM. I'm not sure why this happened, actually. I thought maybe I did something wrong here, but when I look, they were getting the markers problem, and here it's thinking it's 84%. So we are actually evaluating the right problem. Here it's thinking 76%. So they definitely got confused and they did a lot of logic. See, in this case, they got correctly. So yeah, this is interesting that we got these results. So, but this is how they look like. And I'll share a screenshot with this along with the code files as well. So this is where it stands. Like I said, the code files for this will be available in my Patreon. But let's take a look at quickly the chat open source as well. If you were to run this code, then it's just going to ask you which model you want to choose. For example, let's go ahead and pick Llama 8 billion, and it prints which model we are using. Now we can just have a chat with that model. So it's just a quick way you can get some responses from it and compare. Okay, now let's quickly review the code. We are using Threadpool Executor. We are using router chat from OpenRouter Unified, as I mentioned before. I also have the files to do the same with Claude models and GPT models, but I will only be reviewing the open source file. So we set parallel run amounts to 20. That's what we're going to be passing the Threadpool Executor for next auto workers. We set stream to false, combinations to test to 120. So if you use another problem, if you're unsure how many combinations, just set it to 10,000 or something like that. If you want to test a subset of combinations, maybe set it to 20 or a lower number. Here we are making a list of the models we're going to test. And I'm actually running a second run just to make sure that this Marcus result wasn't terribly mistaken with Wizard and Mixtral. I want to give him another chance. So we'll be able to take a look at that at the end. So that's why so I can actually remove this because that's for this particular run. And so this is our first problem. This is our second problem. Feel free to change it if you, but remember that we are shuffling the sentences. So pretty much give the problems as a list and we loop over the problems. We print which problems we are testing. This is like a basic system message I set up. You can feel free to experiment with that as well. When we actually get the results, we have the system message mentioned here. So if you want to test different system messages, you may as well do that. So we split the problem into their sentences. We use itertools to get all permutations. Then we have all combinations. We shuffle those combinations. And we print the number of combinations since each problem has 5 sentences. The total combination is going to be 120 for each. And we have a function which is going to check model responses. It's going to take in the list of sentence combinations. Here's just a default name. This is going to be, we're going to be overriding it. And we call the instance of the router chat with stream variable set to whatever we said in the beginning and the model. And we set a system message. Actually, this should have been router. So I copied this and modified it from the plot test, but it doesn't matter. This will work. You can feel free to change it. We are using router chat and we are setting a system message and the reorder problem. We actually, I'm sorry, this function actually is going to take in a sentence combination from the list of sentence combinations. So since this is also going to be a list, we join it with dot at the end of each sentence and then we just add it to its user as a message, as a user message. And then while true, we're going to try to get a response. Otherwise, we're going to see if we get a rate limit or something. We sleep for a little bit. But at the end, if our problem is number 1, we are checking for 23 in response, otherwise 24%. This will return true if this was the case. And then for the Threadpool executor, that is our function definition. And for model name and model names, we have specified we're going to print which model we are testing. And then with Threadpool executor equaling to the number of parallel run amounts we have specified in the beginning, we are going to actually submit this check model response function, which we talked about right here. To the Threadpool executor, since we've set it to 20, this will start 20 instances at a time. And as those instances are done, as those threads are done, new threads will start. And as those threads get completed, then we are going to check and append to a list, to a results list, whether how many of them were correct. And now we are importing OS just to check the file names in this folder. For example, since I'm running it again, I'm trying to implement an enumeration strategy so we don't overwrite the numbers. That's why. And we essentially just dump it using JSON to dynamically created file name with the model name, the first 10 characters of the problem. That's why we see a bumper and Marcus in the beginning, and an enumerated file name at the end. .json. That's about it. So I hope you enjoyed this. Thank you for watching. This was the end of our video, but I'd like to talk quickly about my OptoStreamer version 3 project. OptoStreamer version 3 is a PyQt-powered PyInstaller packaged Python project that I came up with. It uses your OpenAI API key to create course websites such as this one in real time. This is also deployed at Railway, and including with audio.
The elif clause. In Python,
so you have quite a lot of choices, such as 6 different voice choices and over 50 languages that you can choose from. You can choose light or dark theme. When you go here to generate courses, you just enter a course that you would like to generate. For example, we just did permaculture basics, and I can pick how many chapters I'd like to generate, and I'm just going to go ahead and generate it real quick. This shouldn't take too long. Our curriculum was created successfully. I can go into view course outline and search for that permaculture. And as I can see, ethics and principles, design methods and tools, and practical applications. I can then actually select this course outline and continue to generate the course created in light mode. And then the website will launch automatically and will be created for you in real time. And you can record it as I'm doing right now, or actually live stream it. It's really up to you. And once it begins, we'll be able to
Ethics
pause
of
or
care
stop
for the
streaming.
earth. Permaculture revolves around 3 core ethics, one of which is the care for the earth. This ethic.
I'm going to go ahead and pause it. If I were to let this run, then this entire course will be generated live, and I can listen to it live. I'm going to go ahead and stop. And if I were to let this course be generated, then it'll be under my view and launch generated courses. For example, I just created a course called Financial Basics for. Let's go ahead and launch. It's like this. I can actually switch to light mode as well, I believe. I'm sorry, dark mode. And then I can revisit this course. Both I can zoom in, both is in text, and
the importance of emergency funds.
yeah, it has 3 chapters, which I can easily use. The benefit of this and what you'll get out of it is that instead of chatting with in a disorganized manner, this allows you to create structured courses that you can run and listen to before you go to sleep, or just fill your time. When you have just 5 minutes or 10 minutes worth, you can visit these courses back whenever, anytime you like. So AutoStreamer, you can download a free demo from autostreamer.live. I'll put the link in the description. Mac version is coming soon. You can, if you click on the download free demo, it will take you to my Google Drive download. And these are the files you'll be downloading. AutoStreamerDemo.exe is the same thing as this, except with limited features. And if you wanted to download the full version, then click on this. Will take you to my Patreon shop, where it's currently only for $200 instead of $300. You can read all about it in the website. You do need an OpenAI API key for this to work. And sometimes this is a PyInstaller packaged PyQt Python application, so your McAfee or Malwarebytes may flag it as not good, but as a matter of fact, all you have to do is just make an exception for the program. And if you have any questions, feel free to join our Discord or ask me the question that you have in Discord. Well, thank you for watching, and do let me know what you think of this project. I was really proud of this one. And like I said, the code files will be available at Patreon. And I also have special tiers for one-on-one meetings with me, if that's something you're interested in. And thank you for watching, and I'll see you in the next video.